This video is a review on how to solve for a right triangle when given two pieces of information, such as you're given two sides, or you're given two angles, or you're given a side and an angle. You should be able to find all of the other missing pieces of information from that right triangle. So I'm going to go over all of the different tools that we have. So one of the tools that we have is called the triangle sum theorem. So the triangle sum theorem. And the triangle sum theorem says that when we have a triangle, then angle A plus angle B plus angle C, angle A plus angle B plus angle C equals 180 degrees. We also have what's called the Pythagorean theorem. The Pythagorean theorem says that if I'm given two sides of a right triangle, I can take one side squared plus another side squared equals the longest side squared. And then the last one, if this is especially if I'm given an angle and a side, or I'm given two sides and asked for an angle, then I'm going to use the trig ratios. That's your SO, CA, TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So looking at our first problem here, now I'm given two sides and I'm asked to find a third side. Well, what should come to mind is the Pythagorean theorem. So we have our 10 squared plus 8 squared equals x squared. Well, 10 squared, that's 100, and 8 squared, that's 64. That equals x squared. And then, of course, we add these together to get 164 equals x squared. And then we take the square root of both sides. And then that's going to give us, well, some number, right? That's going to give us the square root of 164, and that gives us 12.8. So x equals 12.8. 8 inches, 8 yards, I don't know, because the units aren't given. Next one, and I'm given an angle. In fact, I'm standing from this perspective right here, and I'm given this angle. And from the perspective of this angle, I have x, which is my adjacent side, and another side that's opposite my 90 degree, that's my hypotenuse. So what should come to mind is the trigonometric ratios of SO, that's an H, sorry, CA, TOA. And out of our choices here, we have adjacent and hypotenuse, so that would be cosine. So I have cosine of 30 degrees equals adjacent over hypotenuse. We solve for x by multiplying both sides by 35. And then we just throw that into our calculator, 35 times cosine of 30. So I have 35 times cosine of 30, and that gives us 30.3. 30.3. So x equals 30.3. So this length right here is 30.3. And it should be, this side should be less than the hypotenuse, so it looks like we're pretty accurate with what we've come up with. About 30.3, that makes sense. Well, let's look at another one. I'm given an angle and a side, and I'm asked to find another side. Well, the trigonometric ratios come to mind again, or they should. And so out of our choices of SO, CA, TOA, well, from my perspective of where I'm standing here, then 13, that's my adjacent. X, that's my opposite. And so out of these choices here, here's opposite over adjacent, so we should use tangent. So I'm going to write tangent of 65 equals opposite x over 13. So opposite over adjacent. I'm going to multiply both sides by 13. 13 divided by 13 is 1. X is now by itself. I'm going to throw this into my calculator of 13 times tangent of 65. And that gives us 27.9. 27.9. So this length right here, if this angle here is 65, then this length right here should be 67.9 whatever units that is. Now this might not look like it should be more than twice the length of here, but this is not drawn to scale. So just mind that when you're doing problems, is that the drawing or the image might not be drawn to scale, and these certainly weren't. I just sketched these and assigned numbers to the particular problem or to the triangle. Now let's look at another one. I'm standing here from this perspective of this angle right here, and from my perspective here, the 18, that is my opposite, and the x, that's opposite the 90 degrees, so that has to be my hypotenuse. So the trigonometry should come to mind, the trigonometric ratios. So we have SO, CA, TOA, and out of the choices here, we have opposite over hypotenuse, that would be sine. So sine of 70 degrees equals our opposite, 18 over x. Now I need to solve for a variable that's in the denominator, so I'm going to multiply by x to both sides, because x divided by x, that's just 1. And so that leaves me with x times sine of 70 equals 18. And because this is multiplication here, I'm going to divide by sine of 70 to both sides, sine of 70. Because sine of 70 divided by sine of 70 is 1, x is now by itself. I'm going to throw this into my calculator. 18 divided by sine of 70. 18 divided by sine of 70. And that's going to give me 19.2. So x, in this case, equals 19.2 units, whatever that particular length is. So this length right here, if this is 70 degrees, and this is a right triangle with the opposite of the 70 being 18, then the hypotenuse is going to be 19.2 units, whatever they are, inches or feet or whatever. All right, so let's look at number 5. Now, I'm given two sides of a right triangle, and I need to find the missing side. So the Pythagorean theorem should come to mind of our a squared plus b squared equals c squared. So a and b don't matter, but the c is critical. The c has to be the longest side. So I have x squared plus 85 squared equals 100 squared. Now, that's going to give me, so we have x squared. I'm not actually sure what 85 squared is, so I'm just going to use my calculator really quick. I have 85 squared, and that gives us some huge number of 7,225. And then 100 squared is 100 times 100, which is going to give me 10, that's just going to give me 10,000. So I should, yeah, 10, that should give me, 100 squared should give us 10,000. So at this point, I'm going to subtract the 7,225 from both sides, 7,225, and that's going to give me x squared equals, and what's that going to give me? It's going to give me 2,775. That looks about right. And then we take the square root of both sides, and that's going to give us, so we take the square root, of this 2,775, and that gives us 52. We have x equals 52.7. So that's going to give us, our x is 52.7 units, whatever that is. Now let's look at the last one. I'm given two sides and I'm asked for an angle. Now if I use the Pythagorean theorem, it's going to give me the missing side, not the missing angle. So what should come to mind is the trigonometric ratios. So I'm standing from this perspective here, from this angle, and from this perspective, our trigonometric ratios again are what? So, ca, TOA. And from my perspective here, the 15, that's my opposite side. And the 7, that's my adjacent side. So out of the choices here, I should use tangent. So I have tangent of our angle equals the opposite side over the adjacent side. And then I need to solve for theta. So I'm going to take the inverse of tangent of both sides. So I have theta equals the inverse of tangent of this 15 sevenths. So I'm going to throw that into my calculator really quick. I have the inverse, oops, that is not what I meant to type in. So the inverse of tangent of 15 sevenths, and that gives us that theta equals 65.0 degrees, 60. And so there you go. The only thing that we didn't do, in fact, I probably should throw this in really quick. If I do have a right triangle, and I'm given a missing angle, such as, I don't know, say 30, and I'm asked to find the other missing angle, then what should come to mind is the triangle sum theorem, where the sum of all the angles equals 180. So I'd have x plus this 90 degrees here, plus this 30 degrees, and then that should equal 180. And then when we combine like terms, we have x plus 120 equals 180, and then we subtract the 120 from both sides, and that gives us that x equals 60 degrees. So in this case, this x right here is 60 degrees. So I hope this was helpful, and have a wonderful day.